3.4 Comparing means from different populations. Do recent male and female college graduates earn the same amount on average? Answering this question involves comparing the means of two different population distributions. This section summarizes how to test hypotheses and how to construct confidence intervals for the difference in the means from two different populations. Hypothesis tests for the difference between two means. To illustrate a test for the difference between the two means, let mu sub w be the mean hourly earnings in the population of women recently graduated from college, and let mu sub m be the population mean for recently graduated men. Consider the null hypothesis that mean earnings for these two populations differ by a certain amount, say d sub naught. Then the null hypothesis and the two-sided alternative hypothesis are h sub naught colon mu sub m minus mu sub w equals d sub naught versus big H sub 1 colon mu sub m minus mu sub w not equal to d sub naught. Equation 3.18. The null hypothesis that men and women in these populations have the same mean earnings correspond to big H sub naught in equation 3.18 with d sub naught equals 0. Because these population means are unknown, they must be estimated from samples of men and women. Suppose that we have samples of N sub m men and N sub w women drawn at random from their populations. Let the sample average annual earnings be big Y bar sub m for men and big Y bar sub w for women. Then an estimator of mu sub m minus mu sub w is big Y bar sub m minus big Y bar sub w. To test the null hypothesis that mu sub m minus mu sub w equal d sub naught using big Y bar sub m minus big Y bar sub w, we need to know the sampling distribution of big Y bar sub m minus big Y bar sub w. Recall that big Y bar sub m is, according to the central limit theorem, approximately distributed big N of mu sub m and sigma sub m squared over N sub m, where sigma sub m squared is the population variance of earnings for men. Similarly, big Y bar sub w is approximately distributed big N of mu sub w and sigma sub w squared over N sub w, where sigma sub w squared is the population variance of earnings for women. Also recall from section 2.4 that a weighted average of two normal random variables is itself normally distributed. Because big Y bar sub m and big Y bar sub w are constructed from different randomly selected samples, they are independent random variables. Thus, big Y bar sub m minus big Y bar sub w is distributed